In our last video, we learned about how to find whether we have certain kinds of symmetry in a polar function, but it turns out there's some very convenient shortcuts we can use. So rather than having to plug in those expressions and see if we get something equivalent, if you know that your function only involves sine, right, like r equals, and then just involves sine, then you know without having to do any math, it'll be symmetric about the line theta equals pi over 2, in other words, the y-axis. If, on the other hand, your function r equals something only involves cosine, it's definitely going to be symmetric about the polar axis. That's the x-axis. So without really doing any math, we can just shortcut to knowing what kind of symmetry we have for those things. So let's try to use that to our advantage to graph a new function, r equals 1 minus 2 cosine theta. So notice, r equals, well, it only involves cosine, so according to my shortcut here, I know it's going to be symmetric with respect to the polar axis. In other words, it would just mirror across that x-axis. So I'm going to plug in a few points here. Okay, so 1 minus 2 times the cosine of 0. So that's 1 minus 2 times 1, or negative 1. Pi over 6. Let's see, cosine of pi over 6 is root 3 over 2. So this is 1 minus root 3, roughly negative 0.7. Let's start to plot those guys. Okay, so at an angle of 0, I'm supposed to go out a distance of negative, so opposite direction, 1. Starting over here. Next, at pi over 6, I'm supposed to go out a distance of roughly negative 0.7. So not this way, but the opposite way, 0.7 or so. Pi over 3. Okay, the cosine of pi over 3 is 1/2. So this is 1 minus 2 times a half, or in other words, 0. So here I am at pi over 3, and I hit 0. Next, pi over 2. 1 minus the cosine of pi over 2. Well, cosine of pi over 2 is 0, so this is just going to be 1. 1 minus 0 is 1. So far, it's looking like this if I connect my dots. Okay, let's keep going. So now let's try 2 pi over 3. Okay, so the cosine of 2 pi over 3, well, let's see, that would be negative 1/2. So this is 1 minus 2 times negative 1/2, or in other words, 1 plus 1. That's going to take me out to 2. Keep connecting those dots. 5 pi over 6. Well, the cosine of 5 pi over 6 is negative root 3 over 2. So this is 1 plus root 3. It's roughly 2.7. 1, 2, and use your calculator if you need for these numbers. Oops, 2.7. And then finally, here at pi, cosine of pi is negative 1. So this is 1 minus 2 times negative 1, or in other words, 3. So at this point, I've got a decent look at this, some kind of spiral looking thing, but I also know I'm supposed to have symmetry about the polar axis. That's what we decided at the beginning. So rather than continuing to come up with more points here, I'm just going to take what I've got and reflect it across the polar axis, or in other words, across the x-axis. So this one stays put, this one goes to the other side, okay, something like that. This one goes to the other side, this one goes to the other side, go to the other side, and that one stays put. So if I reflect that whole picture, it's going to look something like this. So this is kind of like our lima bean shape from before, but it's got this little loop on the inside of it. So it turns out this is another kind of limacone, like what we saw before. But this time we could say more specifically, it has what's called an inner loop. Okay, here's a nice computer-generated version of that graph, okay, just so we can see what that looks like. Okay, so that's our first example of using a shortcut to see what kind of symmetry we have. Okay, so we're going to try another one now immediately, just to see if we can continue to use this. On this one, I want you to decide what kind of symmetry do we have here. Right, do I have polar axis symmetry? Do I have symmetry about theta equals pi over 2? And then we're going to try to come up with a little bit of information first before we graph anything. So symmetry, that's what we did last time. Okay, so it only involves cosine, so I'm definitely going to have symmetry about the polar axis. Now some other information that can sometimes be useful to help us graph. Let's look at the maximum values we're going to find. Okay, so how far out will we get from the origin? So thinking about this, it's 2 times the cosine of something. Well, the biggest cosine could get is 1, right? Or maybe negative 1 would be the biggest negative number we could get. So it'll get as big as 2 and as small as negative 2. Okay, so I'm really only going to go out to that second circle here. Everything's going to be contained in that small little circle. And then finally, it could be useful for us to find the zeros. Where is that thing going to be equal to 0? So let's go ahead and solve that. 2 cosine of 3 theta equals 0. Divide both sides by 2. And now I'm just thinking, where is cosine equal to 0? Well, that's going to happen when we have pi over 2, or 3 pi over 2, or 5 pi over 2, or 7 pi over 2. A lot of different options here. Okay, so let's see, if I divide both sides by 3, I'll get pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, right? And there were more options here too, like 9 pi over 2, or 11 pi over 2. So that's going to be 3 pi over 2, and 11 pi over 6. A lot of different spots where I'm going to end up back at the origin. So there's a lot going on with this picture. What I want you guys to do now is try to plug in these numbers up here, right? Notice they're much closer together because things are going to happen much faster in this graph. Try to plug in those numbers, right? See what you can calculate for these R values, and then see if you can connect the dots with these points. Then see if you can use that polar axis or x-axis symmetry to finish drawing this thing. So see what you can do with this, then unpause the video and see if we get the same picture. Alright, so let's start by plugging in 0. Okay, when you plug in 0 for theta, that's 2 cosine of 0, or in other words, 2. So along this direction, straight out to the right, going out 2. Okay, the next thing I'm supposed to do is go to pi over 12. That's this little faint line right here. Okay, so if I plug in pi over 12 times 3, that's pi over 4. Cosine of pi over 4 is root 2 over 2. Multiply that by 2, it's just root 2, roughly 1.4. Okay, so that's right around there. Pi over 6. Well, we actually decided earlier that's going to be a spot where we hit the origin. In other words, where it's 0. So far I'm going around, and it looks something like that. Alright, well let's try pi over 4. So if I multiply that by 3, that's 3 pi over 4. Cosine of 3 pi over 4 is negative root 2 over 2. Multiply that by 2, it's negative root 2. So negative 1.4-ish. Okay, so here's my angle, pi over 4. But I'm going to go in the opposite direction, 1.4. So straight this way. Okay, so now it looks something like that. Let's try pi over 3. So pi over 3 times 3, that's pi. Cosine of pi, negative 1. Multiply that by 2, negative 2. So instead of going pi over 3 and then out 2, I'm going to go the opposite direction, 2. Okay, so I'm starting to connect my dots. Got some kind of weird oval looking thing maybe. Not sure yet. Let's keep going. 5 pi over 12. So let's see, if I multiply that by 3, that's 5 pi over 4. Cosine of 5 pi over 4 is negative root 2 over 2. Multiply that by 2, it's negative root 2. So here's my angle, but instead of going that way, I'll go the opposite direction, about 1.4. Right around to there. Okay, so it looks like maybe I'm circling back to the middle. Let's see what happens next. Pi over 2, yeah. Okay, so pi over 2, I'm expecting to come back in. So let's see, pi over 2 times 3 is 3 pi over 2. Cosine of 3 pi over 2 is 0. If I multiply that by 2, it's still 0. Okay, now I've got somewhat of a drawing here. What I'm going to do is go ahead and reflect each of these points that I've already got across the x-axis to get some other corresponding points. Okay, so for example, this point right here reflects to right there. Okay, so I'm going to have a picture that looks kind of like that, like a little flower petal. And this entire petal is going to reflect over to the other side. Okay, so somewhere around there. This one is going to go to right there. This goes to right here. Okay, so that flower petal reflects over like that. And really, I'm ending up with what looks like a flower with 3 petals on it. Okay, that's when I do that symmetry across the x-axis, that's what I'm ending up with. Okay, and it turns out if we keep going, we'll just keep tracing over this flower shape over and over again. So it turns out this is what's known as a rose curve. Okay, so we're going to have a lot of different kinds of graphs that we eventually look at. We'll classify those in a later video.